Alright, here's test practice 1 through 4 from the Friday review sheet. All these questions will be embedded somehow into our test on Monday and Tuesday. So let's take a look at these 4 factorable situations and see what they are, what's special about them. Looking at the first one, number 1, 16x squared minus 25, we notice that 16 factors down into 4 and 4. Negative 25 will factor down into positive 5 and positive 5 and negative 5. So quickly we should be able to do this as 4x plus 5 and 4x minus 5. Why that is if you take a look at 16x squared minus 25 and expand it out, what's special about it is that, well, there's no middle term, and that means all of these factors have to cancel out because there's no middle term and it all adds up to 0. So if we use the area model, which we shouldn't have to on these, but if you need to, go ahead and do so. We set it up this way, and what we'll notice is that the only way this will work is if we do use the square roots of these perfect squares, or at least for 16, square root of 16, the positive version is 4 and 4. Negative 25, well, its square root is 5 of the absolute value of 25, but we need a positive 5 and a negative 5 in order to help us cancel out, combining these two terms to cancel out the middle term to 0x. So what's special about these is the perfect squares that are involved. Whoops. Sorry about that. Perfect squares. And if we take that and use that, look at number 2, we notice 9's a perfect square, 1's a perfect square. This is usually called the difference of squares. So 9m squared will factor into 3m, and 3m. Negative 1 will factor into positive 1 and negative 1. And since these two and these two, when multiplied, will cancel out to give you 0m, voila, these must be the factors for 9m squared minus 1. Looking at number 3, we have 4p squared minus 9, and 4 and 9 are perfect squares. That means this can factor into 2p plus 3 and 2p minus 3. And there's always the question of, can you have the 2p minus 3 in front? Yeah, that's perfectly fine. You can have the answer as this as well. Bam, just like that. Number 4 is one of the ones that are special because if you look at this, before we want to factor into binomials, you notice that each of them have n, so let's factor out or divide out an n. The numbers are 3, negative 7, negative 10, so the numbers won't break down any further. But taking out the n, or dividing out the n, I should say, helps us to break this into something smaller. And then using the area model, we can try different patterns, 3n and 1n. You're going to have to look at the factors of negative 10, which are going to be plus or minus 1 and 10, or plus minus 2 and 5. You notice the only thing that will work is when you multiply, let's see what works, negative 10 here and positive 3 here, is negative 10n. Ooh, no, that doesn't work. Let's back up. Bam, 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 bam. So if that doesn't work, we try something else. What factors will work? 3n. Oh no, it does work. It does work. It does work. 3n minus 10 Oh, so yes, minus 10 and, oh, it does work, plus 1, so plus 3n. When you combine these two n's, we get negative 7n. So our final factors of these will be n times 3n minus 10 times n plus 1. Alright, thank you.